Hello and namaste everyone. This is me Samita Rimal and I am presenting on my research project titled An Experimental Investigation of PAT Pump as Turbine in Direct and Reverse Mode at Turbine Testing Lab TTL. In our group we have Dr. Biraj Singh Thapa, Engineer Nischal Pokharel, Engineer Sanjaya Pd Sah and me myself. Moving forward towards the First, the contents that I will be covering in this presentation include a background of the project, past researches that have been done in this field, in the field of pump as turbine throughout the world, research motivation, what really motivated us to choose this topic and perform an experimentation with a PAT, the objectives that we had set during the project period, scope and limitation of our project, the theoretical framework, physics behind the running of PAT, and the methodology, the step-by-step methodology that we undertook during the process, results that we have obtained, conclusions, future work and recommendations, and then finally the references. Moving So talking about the background of a pump as turbine, first of all, going through the micro and mini hydropower here at Nepal, uh, uh, they are preferred as compared to the large hydropower plants because the large hydropower plants require high initial investment and also the payback period is very large. And then in Nepal, the total installed capacity of pico hydro, micro hydro, and mini hydro combined is close to 30,000 kilowatt. And then the history of micro hydropower started with the enthusiasm to improve the water meals and also to generate electricity of nominal capacity. The figure in the top represents shows the first micro hydropower installed at Nepal. And in Nepal, there are nearly 100,000 ghattas, also known as the traditional water mills, that are installed all over the country. And since it is very difficult, time consuming, and costly to develop the site specific turbines, since they have to correspond to the local ecology, this is where can come into existence. The figure in the below show the same thing that shows the cost distribution of large and micro hydropower plants. In the large hydropower plants, the cost of electromechanical equipment is only about 20% of the total cost, whereas in the micro hydropower, the same cost is twice as much. So since the turbines fall into this category, if a pad can be utilized, then the payback period can be reduced and profit generation can also improve. Also, the in the places having nominal capacity to generate the electricity, it can be very effective. And the background of different types of turbine is shown in this presentation. The first one is cross flow turbine. And since a cross flow is a large turbine which runs at a lower speed, it requires belt drive to power the standard generator as shown in the top figure. In the Pelton turbine, it is a bit of a complex arrangement since there are three or four jets, normally three or four jets, and there is a casing present and there are nozzles. So it is a kind of complicated arrangement if we think of micro and mini or pico hydropower plants, the arrangement becomes very complex. And then in the Francis turbine, more number of components are present and it is expensive than the cross flow turbine. So when we talk about PAT or pump as turbine, it is low in cost, the complexity is less, and since the pumps are produced in mass, unlike the turbines, it is easily available and also the spare parts are available. Then availability of wide range of heads and flows for PAT, which can be also seen in the figure on the side that we can see that the red line it shows the area of head and discharge where a pump can efficiently operate, and it kind of overlaps in the area of a closed flow turbine shown with the blue line. It overlaps with the Pelton turbine shown with the purple line, and it also overlaps and it greatly overlaps with the Francis turbine of Green Line. Also, the pump is easily installed, and then this graph shows that pumps can be used within the range of that head 10 to 100 meters head and the discharge and certain discharge where it can run efficiently. The past researches that have been done in this field is presented here. The efficiency of PAT is usually found lower than the conventional hydro turbines, which is correct because the turbines are site specific and are made to maximize the efficiency, whereas the pumps are not. And then the maximum turbine efficiency obtained from a PAT is nearly 76%, which is comparable to the efficiency of cross-flow turbine and is satisfactory. Also, if the also efficiency of 80 to 100% can be obtained for fixed load applications in case of PAT, and PAT in the range of 1 to 500 kilowatt. The payback period is just 2 years. So the graph in the side represents the efficiency versus discharge of different kinds of uh, turbines and pump, and it can be seen that a pad shows efficiency only after reaching Q40, whereas other turbines start to gain efficiency as soon as they reach 5%. But in the meantime, when in the meantime they reach comparable efficiency in the Q80 region. It shows that efficiency is very comparable, and also application of various pump as turbine is shown in the figure below, where different types of pad can be utilized on the basis of head and flow rate. For example, centrifugal pad can be used in the head range of 10 to 100 meters and in the flow rate of 10 to 100 liter per second very effectively. Also, mixed flow pad can be used in this region. So the graph shows application of various pumps as turbine in which region it operates very well. And then the research motivation, what motivated us to perform this research was that the performance evaluation of pump in both the direct and reverse mode for the readily available pumps in the Nepalese market had not been performed in laboratory conditions, and the importance of BAT in micro and mini hydropower has not been realized in Nepal yet, but it has been realized and practiced in other countries. For example, a picture of a centrifugal PAT-based pico hydropower station is shown, which was installed in west of Iran. And this type of arrangement and this type of practices is not seen here in Nepal. Also, in the next figure, we can see the parallel arrangement of a PAT in mini hydropower plants, where the pumps are arranged in parallel to generate electricity. And then the prospect of replacing traditional water mills with PAT has not been studied. As I mentioned in the second slide, that there are 100,000 traditional water mills in Nepal, and some of them are operating and some are not. And the prospect of replacing those traditional mills with PAT has not been studied in Nepal. If they are replaced, then nominal electricity can be generated, and it could be very beneficial for the rural community people. So the objectives that we set during our project was that the identification of a suitable pump for laboratory testing in direct and reverse mode, the experimental testing of pump in pump as well as turbine mode at the laboratory conditions, and to develop a reference test rig for pump as turbine inside the turbine testing lab. This The scope and limitations of our project include that the study is solely based on the pump available in Nepalese market, the experimental study of pump performance in direct and the reverse mode. The limitations include that the modification of pump impeller for efficiency improvement was not carried out and the electrical components are not studied during the period. So the physics that governs pump as turbine is shown here. In the pump, we can see that the suction is the suction side is same to the outlet of the turbine mode. The suction side in the pump is same to the outlet of the turbine mode, and the discharge of the pump is same as the inlet of the turbine. And since the flow direction and rotational speed are reversed, the velocity triangle of both the mode changes, which is shown in the down in the figure at the down, which shows that the velocity triangle of a pump outlet and the velocity triangle of a pump inlet. For the study, the outlet flow angle from the impeller uh, assumed to be assumed to be equal in the reverse operation, equal to the impeller flow inlet flow angle in the direct operation, and then doing this, the Euler heads could be considered same in both the modes, which is it could be considered HPE equals HTE, and the Euler equation that we use for efficiency calculation is shown in the equation here, and the total hydraulic power developed was calculated using this formula where P equals rho QGH. So the methodology during the process include literature review. First, different types of pump was studied, and selection of a suitable pump to operate in both the modes. Pump market survey to Pump market survey was done to see if the pump is readily available or not, and the selection of pump available in the Nepalese market was done, followed by experiment of pump, that is experiment in the direct mode, which was followed by experimentation of the pump in the turbine mode inside TTL, and then the data analysis of the results that we collected during the both the experiments, and finally a conclusion was drawn based on the data analyzed. So the schematic diagram of the setup in the pump mode and in the turbine mode is shown here. In the first picture, we can see that the schematic diagram of for the experimental testing of pump in direct mode is shown, where in the setup a pump to be tested is present, pressure gauge is present for the pressure measurement, there's a flow meter for the regulate for flow measurement, and the butterfly valve is present for regulating the flow, and a dump load was used. A Francis turbine was used as a dump load, and there is a sump where from where the water is circulated throughout the system. And in the schematic diagram for the pump testing in reverse mode, there is the presence of pump room at TTL, barometer, high pressure tank which pressurizes the water before entering the turbine, flow meter for flow measurement, valves for regulating the flow, and the turbine which is PAT, and the reservoir from where the water is circulated throughout the system. So the literature review that we performed in the course of the project is shown here. Regenerative pump turbine was studied, and since it is a high pressure and small capacity, it was uh, discarded from being used as a pad. And then we studied the semi-open impeller, which was for non-viscous fluid, and it is not applicable for water. Industrial impeller was studied, which was a closed type impeller. And finally, we selected a 3.75 kilowatt end suction centrifugal pump with specific speed 43.42. It was a closed type impeller and similar to high head Francis runner. And then we also studied fundamental theory of pump used in turbine, past researches that have been made on PAT modification in the pump impeller for efficiency improvement. These all things were studied during the course of time. For the experimentation phase, after the pump market survey was done and a suitable pump was selected for testing in both the modes, development of direct and reverse test rig for efficiency calculation was done. The first picture shows the experimental setup for pump testing, where the pump is seen in the bottom portion, and the same setup was um, taken inside the turbine testing lab, and it was tested for in the turbine mode. Then the performance evaluation and analysis of pump in both the modes was carried out. The results that we obtained are shown here. The first picture shows efficiency versus flow rate in the pump mode. We can see clearly that as the flow rate increases, the efficiency kept on increasing, and at a point, at a flow rate of 4 liters per second, a maximum efficiency was obtained, which was equal to nearly 61%. And then after the point, efficiency kept on decreasing as the flow rate was increased. In the next picture, we can see that efficiency versus flow rate of a PAT is given, and as the flow rate was increased, efficiency kept on increasing in PAT, and it reached a maximum efficiency of about 40% when the flow rate was nearly 11 liters per second. The comparison of head versus flow rate in the pump and head versus flow rate in the PAT is shown here, where in the pump, as the flow rate increases, the head kept on decreasing, and when the flow rate was 4 liters per second, the pump head was 18 meters, and as it kept on decreasing, the head of nearly 2 meters was attained when the flow rate was 12 liters per second. Similarly, in the case of a PAT, as the flow rate increased, the head attained kept on increasing, and when the flow rate was 3 liters per second, 1 meter head was attained, whereas when the flow rate reached 11 liters per second, maximum head of about 12 meters was achieved. The output power versus input power of the PAT is shown in the first figure, where as the input power keeps on increasing, the output power also keeps on increasing, and it reaches a point where 0.45 kilowatt output power is achieved when the input power was 1.3 kilowatt. And in the case of output power versus the head of PAT, as the head keeps on increasing, the same output power, that is 0.45 kilowatt, was attained when the head was 12 meters. This slide shows the efficiency versus flow rate at various RPM and head versus flow rate at different RPM of the pump. It is clear that as the flow rate increased, the efficiency obtained from the pump also kept on increasing, and at the RPM of nearly 2750 RPM, maximum efficiency was obtained, which was 60% at the flow rate of 11 liters per second. And similarly, at the head of 21 meter was obtained when the flow rate was nearly 8 liters per second at the same RPM, which is 2750. So the conclusion of the research is shown in this slide. The maximum efficiency of pump was obtained 60.85% in the direct mode, which is comparable to the rated efficiency of the pump, and it was obtained at the best efficiency point where the head was 17 meters and a discharge of 17 liter per second. Then in the case of pump as turbine, maximum efficiency of 40.15% was obtained at a flow of 11.5 liters per second and at a head of 10 meters, which shows that the centrifugal pump can satisfactorily operate in turbine mode without any modifications, and there is a huge prospect of introducing PAT in mini and micro hydropower of Nepal and replacing the traditional water mills with PAT. Since I mentioned in the second slide that there are 100,000 traditional water mills present throughout the country, there is a huge prospect of replacing these traditional water mills with the PAT so that nominal electricity can be generated at areas like this. Also, the future work and recommendation is that to achieve higher efficiency of the turbine, it is recommended that the turbine be tested in full flow conditions, and the modification techniques like the rounding of blade, inner and outer shroud rounding of the impeller inlet is vital for the improvement of efficiency, and with proper modification and laboratory testing, the scope of the project can even go up to the installation in the suitable sites, which is in the pico hydropower stations or in the places where there are traditional water mills. And these are the references that we referred during the project period for literature review and for efficiency improvement studies. And thank you for your attention.